So my name is Tim Chrisman. I'll be chairing today's panel. I am a American Military University alum and a former Army officer, former CIA Space Department officer, and current executive director of an organization called Foundation for the Future. So today, our topic is going to be a little off from what the program said. It's called a spaceport, I believe, in the program, which is part of this. But it is a broader look at the role of government in investing in the boring parts of getting to, from, and through space. With us today is Michael Fitzgerald from Galactic Harbour Associates to talk Earth to space elevators, Michael Laine from LiftPort Group to talk lunar elevators, and Allyssa Carson to talk getting us to and from Mars in a somewhat survivable fashion. So the foundation that I represent is a single issue nonprofit. We are here only for the standing up of a United States port authority, a frontier infrastructure administration, a federal entity to slide in between NASA and Space Force and handle the essentially highways, railroads, seaports, and other basic infrastructure that the government invests in every other domain. But for some reason, they don't in space. So our general proposal calls for this Frontier Infrastructure Administration, or a federally chartered corporation on the order of the Postal Service, the Tennessee Valley Administration, or any of the handful of government loan guarantee corporations. Now, we're proposing this corporation style structure as a way to both maximize the return on investment from the government to what actually comes out the other side, to minimize any fiscal year delays, to and otherwise streamline the process, both in creation and in execution. As the majority of the foundation's members and sponsors are current or former government, we don't have a desire to have Army privates or Navy rankings out laying brick, floating through space and repairing things. There are smart people to do that. The government has a role in funding, but otherwise it's our view we're trying to limit that. The organization we're proposing here, I'll outline a little further before handing it over to Michael Fitzgerald to talk one of the initial projects that we propose. But it would have 3 offices. The first would be organized generally as a development bank, providing loan guarantees, direct loans, and some form of grant system for basic research into infrastructure development. The second entity would be the Port Authority itself. This is, think, Federal Board of Harbor Masters that manages the integration of space into the intermodal transportation and logistics network throughout the world and manages the actual flow of people and cargo. And finally, this Center for Space Studies, where the federal government's research and development into space infrastructure, space policy, space law can be encapsulated into a single entity as sort of the belly button for research. So with this Space Development Bank, the first of the three organizations. I have up here a handful of different projects that we propose as the sort of aspirational and inspirational infrastructure projects that America doesn't do as much anymore. In the 1930s, we had the New Deal. We built the Hoover Dam. In the 60s, we went to the moon. 80s and 90s, built the internet. So long as America doesn't have a sort of impossible goal, we aren't living up to our true potential. And so these projects are all technically possible. Two of the speakers will talk about some today. They're not challenges in the sort of sense that time travel and other science fiction concepts are. They're challenges in a sense that they require us as a country to come together and build as a unified entity. And with that comes the trade-off that we get a public good on the order of the interstate highway system, the transcontinental railroad, the Panama Canal. The second entity, the Port Authority itself, less cool, exciting projects, more of the backbone that keeps all of this running. I said at the outset, we want the boring parts of space, and I mean it. NASA is exploring the solar system and beyond. Space Force is defending the country. Those are hard jobs. We want the boring middle part that involves the stuff you don't think of until it goes wrong. The final entity, the Center for Space Studies, would, in a similar fashion to how the US National Lab system unifies federal research into a lot of more basic and forward-looking things, this would do that for space. So whether it's the technical side under the Space Elevator Institute, the more basic physics and astrobiology in the National Space Laboratory, or the policy and law analysis that is traditionally done by think tanks under the Academy. These are the moral underpinnings and engineering backbones required for the rest of this organization to do its job. I'm trying to limit my talking as much as possible to be just provide you an overview of what we're doing, where we're going, and devote as much time as possible to the people who are actually out there developing, designing, and working towards some of these projects. So with that, I'd like to hand it over to Michael Fitzgerald.
All right. First of all, let me check everybody's seeing my first screen. All right. This is, it turns out to be the backup slides, but that's okay. We'll go forward. I have obviously last week's slides up. I'm going to talk about the space elevator, and where's the button that goes forward?
I think I've got that, Fitzer. I can.
Yeah, you got to click over to me here in a minute. There you go. Okay, this is me. I'm Fitzgerald. I'm a board member of the International Space Elevator Consortium, but my background is largely military. Graduated from the Air Force Academy in '68, got a master's in '78 on R&D management, and have spent most of my time in huge projects, and I mean huge, including ICBMs and, as I call them, funny-looking airplanes. And I hope you all smile knowingly as to what that's all about. And I left the military business about 6 years ago when they were still fighting about what hypersonic meant. Okay. Click. Once again, it doesn't want to click. I want to talk about what I call the Galactic Harbour. This is a term I put together in the light of nobody really understood exactly the pedestrian version of things as to what the Galactic Harbour meant. And what I do here is go back to look at a harbor that exists right now. This is the Los Angeles Long Beach Harbor. And I live right over here, about halfway down the image under the A. And I have seen this thing transform in the last 30 years from a dry harbor, we used to call it, to the container harbor that is part of the intermodal transportation system of the planet Earth, as I say. Click. The basics of what I'm going to talk about are shown here. The basics are, first of all, that the space elevator part of the Galactic Harbour is called the Space Elevator Transportation System. Okay, and it's shown on the right-hand side. It is 100,000 kilometers tall, 100,000 kilometers, 66,000 miles tall, goes well beyond geo. It is composed, however, of a transportation system, which is, as shown in the previous chart, I showed you the main channel in the harbor. The Space Elevator Transportation System is the main channel in this harbor. And I'll tell you about the pieces as I go along. The second part of the Galactic Harbour are all of those businesses. The LA Harbor amazingly employ 150 to 200,000 people showing up at work every day down there. Almost 1 million people in the southern USA, or in Southern California. Over almost 2 million, count all the various people that work on this out towards Denver and Boise, okay? The harbor has incredible employment reach. We are looking to reconfigure that to be a galactic harbor and employ just as many people eventually. LiftPort is obviously where the Galactic Harbour is attached to the planet Earth. Our baseline concept is that it's in the middle of the Pacific. I won't go through the whole rain dance of why it's there or not there, because it can be elsewhere. I'm not denying that. But for the sake of having a baseline, and anybody that's done an engineering project, is you gotta have a baseline. You can change it later, but you gotta have, click. This is the LiftPort. It's composed of the georegion after the connection down at the planet Earth. The georegion is up at synchronous. Now look, everything that's gray in that image is part of the Space Elevator Enterprise System. That's where all of the businesses will gather. And the transportation system are those two blue tubes that go right through it. They'll stop off and drop off stuff to whoever ordered stuff. And look at it closely. It's 200 or 300 kilometers across and slightly more than that tall. That means if I laid that image down, it would cover most of Southern California. It's a huge place. It's an enterprise zone. It's where business will be done. When I first joined the Space Elevator Project 7 years ago, the georegion was about 250 to 300 meters across. This is 250 or so kilometers across and just as big. There are a number of companies out there that imagine themselves living at geosynchronous and doing business. We think they'll go here because they'll be serviced by the transportation that the elevator brings. Click. This is the apex. And this is the story yet untold, or not very clearly. This is where interplanetary flights will occur. Now, if you were Sandra Bullock, I'm sorry, Allyssa, if you were Sandra Bullock and you stepped off something near the geo, you wouldn't go too far. You'd kind of wander off a little bit because you would stay in synchronous speeds. But up at the apex, you're going much faster, and you would zoom away. Well, what we intend to do very clearly and right between the eyes is that we're going to take that latent speed and make it the source of interplanetary travel. If you step off the apex at the right moment, you'll be on the right vector and you'll head off, and I'll show you what that means in a moment. Click. It is a mega project, and I won't go through what that means. It means that special attention has to be paid for the long-term planning of a project, and how do we get reliable, safe, and efficient access to space. And that's a story in and of itself. It's much akin to the Panama Canal story, which is, correct me if I'm wrong, there's 2 or 3 failures before we got the Panama Canal. Click. We here in the space elevator transportation system is a certain elixir. It's that latent speed. Any mass, click, that steps off at geo stays at geo speed. If you look up here at the next level at 100,000 kilometers, which is where the apex is at this point in the baseline, that 7.7 kilometers per second is enough delta velocity to get all the way to the moon. Excuse me, all the way to Mars, all the way to Mars. I mean, okay, Amazon, are you listening? We're talking about free delivery here. Now you got to stop when you get there. So when an Amazon truck stops in front of my house, I think of my elixir story here. At the top, it's 163,000 kilometers, and 12.3 kilometers per second is enough delta V to leave the solar system. That's the story. If you can put something down at the LiftPort and have it climb the cable, as it were, the TED we call it, you could go anywhere in the solar system. Delta velocity is free. That's an amazing story. And that's why Tim talked about the Space Elevator Institute, why he talked about the laboratory, because this is raw information that we want to take advantage of over the next century. Some people say it's essential that we figure this out. I'm just stuck in my dream. I want to make this happen. That's the story of the transportation story. Now, Michael Laine, my good friend Michael Laine, 2 Michaels on one show, that's kind of exciting, is to tell you another story, and we are not setting his story aside. We also are not setting Elon Musk's story aside. It's a cooperative and collaborative rain dance that we have to figure out. And once again, why we need an academy and a Space Elevator Institute, or excuse me, Space Elevator Institute. There's more to be said here. Now, the young people at Arizona State, down to the lower right, Tim, James Torla, and Professor Pete, have published all these things about very fancy title, optimization of, send me an click. Oh, I should define how the bigness of the problem. Right now, it looks like 175,000 metric tons per year kind of gets the job done. A single elevator, single line can do 1/6 of that, so you need 6 lines to get 175,000 metric tons per year. Click. Why do you need 175,000? Well, we made a quick check. The people that want to do space solar power up at Geo, build the solar panel, send it down to Earth. The people want to get nuclear material disposed of, and all those other emissions down the left-hand side, they got big mass requirements. They want to deliver mass everywhere. This is humbling. This is humbling. The size of this job, the importance of this job. And I'm not going to stand in front of anybody that wants to help. You can do it first or second or concurrently. God bless you. Click, and I'll get off the stage. We think there's a network needed. Let's put the network together. They call me Fitzer. That's my email address. Send it to me at Galactic, Harbour, or ISEC. If you want to be a member of ISEC, 25 bucks, what the heck. This is our time. This is the transportation story. Okay, Michael Laine, you got the story. Go for it.
Thanks, Fitz. Before I really jump in, I really want to stress something that Fitz said that could have been really easy to overlook. First, ISEC has been around for a long time, and the International Space Elevator Consortium is really kind of maybe the guiding light in how to get this done. My background, my role in all this started nearly 20 years ago as part of the NASA Institute for Advanced Concepts research team. I focused initially on the Earth elevator. At the time, that was, we thought we were very, very close to carbon nanotube technology breakthroughs that looked like it was very promising and very, very near term. You can kind of see in the background behind me, I have a set of robots and strings and all that stuff over in the corner there. That's us doing, kind of the hard work of trying to figure out what kind of string we need, what kind of robots we need. The ability to climb seems pretty trivial on the surface, but it's actually pretty complicated. So LiftPort, our company, I was the second person on the NIAC program, but then once that ended, I created LiftPort in 2003. We worked for about almost 5 years, built a team of about 14 people to grow this thing. And, we're a private company, and our capital collapsed when the real estate markets collapsed in 2007 and 8. And we went out of business. We closed down, but it's during that kind of dark days for LiftPort that ISEC and a couple other organizations around the world, Japan has a space elevator community, Europe has a space elevator community, that those organizations kind of kept the embers warm after our company failed. And really, I don't think we'd be talking about this any longer if ISAC hadn't come in, stepped into the game, and kept things going. So hats off to those folks. Fast forward to 2017, we'd been out of business for 10 years. We decided that it was time to restart the program. For us, it was a shift in focus, not to diminish the work that ISEC is doing on the Earth elevator, but we shifted gears to focus on the moon because it seemed like it was nearer term, closer, easier to accomplish. And so we decided to focus on building a lunar space elevator infrastructure as perhaps a stepping stone to the potentially more complicated systems of the Earth elevator and the Martian elevator. Fitzer didn't really talk about that very much, but that's in the roadmap as well. So we've been doing some work on this stuff for a long time. We actually stopped doing carbon nanotube work quite a few years ago, not because we didn't have any confidence in it, but because my team itself wasn't that good at it, and there were lots of other organizations around the world that got to be a lot better at carbon nanotube development and nanotechnology. What we want to do is build out a lunar elevator. So if you can imagine, you've got the Earth on one side, the moon on the other. Right about here is the gravitational middle, the Earth-Moon Lagrange 1 point. it's not the physical middle, it's the gravitational middle. And what we want to do is we want to take a normal conventional rocket, get out to L1, drop a string down to the surface of the moon, stick it in, stay there so it's attached into the moon's surface, pull that string back towards the Earth, not touching it because it's still a long ways away, but that the gravity of the Earth keeps the string straight. And once you have that, once again, you can climb back and forth from the surface of the moon. And by doing that, you suddenly have a very easy soft landing solution to the moon. The trick about the Earth elevator is getting off of the Earth. The trick on the lunar elevator is landing softly and safely onto the surface of the moon. So two different distinctions there. The Earth elevator is sometimes called a centripetal elevator because it's a ball on a string spinning it over your head. The lunar elevator is sometimes called a gravitational elevator because you're using a different tool, if you will, gravity, to make the system work. But by building the lunar elevator, you also get the very valuable asset of that string that's attached to the surface of the moon. It's a great place to put a space station there at L1. And so you have a permanently attached space station at L1. And it's not going to be a space station the way our beloved International Space Station is, with just a few people at a time. This is a space station that will be, a city in space. And that sounds like hyperbole. That sounds like science fiction. I assure you we're not. It's not. We are very close to that level of technology. So what we want to do, as Fitzgerald was talking about, using the spin of the Earth to push us out deeper into the solar system, until we get there, the next best way to do that is start from a gravitational neutral point. If you leave the L1 point and go anywhere else in the solar system, the delta V of that is 0.14. Fitzgerald showed you numbers about leaving the solar system, leaving the gravity of Earth. That's anywhere from 5 to all the way up to 13. I'm talking about starting points at 0.14, which is almost gravitationally, energetically free anywhere in the solar system you want to go. So until we have the Earth elevator, this might be the first best starting point to the rest of the solar system. So that's what we would like to see. And by having this extraordinary space station with all the capabilities of mining, lunar mining, capturing ice, turning that ice into rocket fuel and water and all the other things you can do with it, you then use that as necessary infrastructure for developing out the rest of the solar system. Of course, some of that stuff is going to come back to Earth, but by having this space station there, this enormous space station there, it gives you a lot of options for whatever else you want to do in the solar system. So that's our plan. It's not as expensive as some of the stuff that Tim was showing on his budget. I will say it's, quote, only $800 million. And when you're looking at your own personal checkbook, usually $800 million seems like a really big number. But when you're talking about, I live out in the Seattle area. Seattle has 5 different multi-billion-dollar projects that are infrastructure projects. The city of Seattle could do this. Certainly the United States of America could do this. It's almost at the level of rounding errors. It's almost at the level of noise considering the budget that we're talking about at the federal level. So what do you get if you do this? What's the payoff if you do this? Well, we are a private company, so we definitely measure our payoff in dollars and cents and return on investment. But the payoff to the nation is advanced technology, robotics, computing, communications, energy, biotech, nanotechnology, materials, all of these things are byproducts that we will use down here on the ground, making life on Earth better. I don't know if we're allowed to answer questions right now. Somebody's asking about lunar elevator attached to the Earth. The lunar elevator is not attached to the Earth. It would be attached at the equator on the moon. Yeah, so that's kind of what we're trying to accomplish. It's a short-term project compared to lots of things in space. We've got timelines that look to 5, 7, 9 years, that kind of time frame. The technology is available. The string, the materials are already available. The rocketry is improving every single day. It's one of the reasons we got back into this. Again, Fitzgerald made a point I want to highlight. This is not in competition to the established rocketry programs that are out there. This is an extension and an expansion of that. The stuff we're trying to do wouldn't really be possible were it not for the breakthroughs that those folks are having. So the rocketry, the robotics, the nanotech, all of that stuff is here. And then the other part that's really important is that the infrastructure that's being created on the moon without what we're doing, completely separate from what we're doing. There's about 95 missions scheduled to go to the moon before this decade is out. 72 of them are American missions, and almost all those 72 have commercial programs either leading or active partners in that lunar development. So this stuff is happening. It's happening right now. It's happening around the world. And I think that the idea of building a spaceport authority that can leverage the technologies and the energy that's already happening would be a really great step in the right direction. So that's all I've got right now. I'm going to pass it over to Allyssa. Thank you very much. I'm happy to answer questions later on.
Hey, thank you so much. I guess to start off just a little bit about my background, just to kind of get you guys, I guess, caught up and that sort of thing. Basically, I am a second-year astrobiology student. So obviously with hopes to get involved in the space industry in the future. But basically, ever since I was a little girl, I was always interested in the idea of space, possibility of traveling to Mars one day, those sorts of things. And I've really been trying to build a resume or get involved in as much research or things going on related to astrobiology or space in general, kind of along those lines. So, I mean, when I was younger, I went to space camp and that sort of thing. But more recently, just getting involved in different sorts of research, whether that's microgravity flights, testing different spacesuits, working with different types in different G-forces, that sort of thing. And yeah, just continuing through my education. But what I really want to kind of talk today about a little bit is just kind of bringing everything kind of back together. Obviously, we've heard different ideas, different kind of crazy dreams that we all have and what we want to do in space or on the moon or on Mars and things like that. Obviously, there are big plans when looking, eventually towards Mars, mission to Mars, looking for possible signs of bacterial life, Mars colonies, terraforming. So there's definitely a lot of big ideas there. And I think, as we've seen, there's a lot of big ideas with space in general. And I think that's just because space is so open and has so much opportunity for us to actually explore or do things in, that really we just have so much room to have all these crazy ideas. And I think that's something that's really amazing about the space program just in general, is that we are able to have some of these ideas that sound kind of wild, like Michael Laine was saying, how it kind of sounds like science fiction. All the different things that we're starting to do in space really was science fiction to us at some point, but now because of space and because of the things that we have done, we're able to make those things a reality, develop those technologies and get closer to that point. So I think that that's something that's really cool and something that we will continue to see develop in the space industry. For a long time, the idea of like colonizing Mars or even terraforming Mars even still is kind of an idea of science fiction. But as we continue in space, whether that is traveling to Mars or traveling to a moon of Jupiter or and beyond and that sort of thing, we will eventually to develop traveling faster in space and those things that we're used to seeing in those science fiction stories. But I definitely think that it is super interesting to start having these big ideas like space elevator, moon elevator, or all the opportunity of working in space. I think that's something that's also pretty special to the space industry is just, we've talked about how many jobs would actually be brought to the industry if these projects were to continue to go through. And I think that the idea of the amount of jobs that actually play a role in space is really amazing. Looking back to when we were going to the moon, we had, like 400,000 people working on this small little project to get people to go to the moon. And so many people were involved and dedicated to that. And I think that in space, that's really what we're looking for next. The next big thing for us to dedicate so many jobs and time to reap the benefits. And I think you kind of mentioned a lot of like the technological benefits of either having some sort of station in space or workspace up there, whether that's on the moon, the benefits of kind of being on the moon, but also just all the benefits that kind of brings back to Earth. We already know that all the different technologies that we're going to be developing can continue to be brought back here on Earth. Those technologies can be used in other places, not to mention the scientific benefits. And that kind of goes along with the mission to Mars. We have rovers and robots and satellites that have kind of done all this science up to this point. But now we're really looking at really getting down to the nitty gritty science and wanting to learn as much as we can so we can really see how realistic these big ideas are. And, I know for me, I absolutely love kind of big, crazy ideas. I know that when I was younger, saying that I wanted to be an astronaut and go to Mars, it was basically one of the craziest dreams and ideas I could have picked at the time. But I didn't necessarily let that discourage me. I kind of still had my head screwed on straight and I had my blinders on for Mars. And so now the more I've worked towards that, the more it's actually becoming a reality. And I think that's the really awesome thing about kind of these crazy ideas is that they really can become a reality the more hard work and time that we put into them. Because definitely when I was talking about this, we were still in the shuttle program when the shuttle program ended, and then everyone thought space was closed. And there were definitely many different periods along that way. But the dream of going to Mars is definitely becoming more of a reality and something more feasible. And I think it's going to be the same thing with these other ideas that we have in space. Just continuing to put in the time, continuing to put in the support for these ideas. That's kind of the biggest thing that I believe that the general public can do for these big ideas in space is just to show their general support. I think that almost everything we do in space comes from public interest. We all have to be excited about to do it. I think that's kind of where all the hype about a mission to Mars has come about. We've seen Matt Damon go to Mars, so now we can actually go to Mars. We're kind of at that point. So I really hope you guys just continue to see some of these benefits of all the ideas that we're talking about, and be able to kind of give your support or be open to the ideas of continuing to give us that public interest and show us that you are interested in these ideas in space, because space is the future. We will continue working towards bigger and better ideas in space, developing new things in space. We're going to continue to do that, try to reap as many benefits off of having working places in space, science in space. I guess I'm going to throw it back to Tim, I suppose.
Yeah, so before I open it up for questions, I just wanted to kind of wrap things up. Alyssa was just mentioning a lot of the benefits of space exploration, of trying things in space, of just taking the risk, comes back to Earth. GPS brought us trillions of dollars in economic benefits. Medical experiments on the ISS brought vaccines for diseases in ways we never thought could be treated. And the future of space industry, of space infrastructure, of space exploration promises to be the sort of exponential growth that we saw after the internet started becoming mainstream, after mass production became standard, And so we have a chance to shape that, to be intentional about where investment goes, in how investment is spent, and realize this dream of developing a new frontier. America was built on the idea of a frontier, but it was always an ideal that could never quite be realized because it involved harming someone, something, or exploiting the area around us. And now we have a chance to see gold in the hills, whether in the form of space-based solar power, lunar mining, asteroid settlements. And the risk is only assumed by those who go. Alyssa's going to Mars. It doesn't hurt me that she's going to Mars to build a home. She assumes the risk, she reaps the benefit. That is something unique about the environment that we are banding together to develop. And we see now is the time to do it, whether it is realizing that we're all at home because of some variation of continued lockdown, whether it's recognizing in government that investment in our future is needed, or it's millions of people realizing that they want to have a hope for tomorrow. Now is the time. Now is the time to join hands and realize the dream of Apollo that started 70 years ago. And so it's our challenge to this generation that by the end of this decade, we develop space. That by the 70th anniversary of Apollo, July 20th, 2029, that Fitzgerald and the Earth Elevator team are sending Pathfinder climber cars up tethers, that Michael Laine and LiftPort Group are delivering fuel materials from the moon, and that Allyssa is hanging a sign on the street outside her house on Mars. We took a vacation in Apollo, and now Artemis is a house hunting trip. We're proposing we set up a home to live in space. We hope you'll join us. And if you have questions, I'm not sure how that works. I know you can type them, but otherwise, reach out to us. Our contact info is here. And yeah, see you out there.
There have been some questions from some of the attendees. I'm gonna read off some of them and answer. Fitzer, the first one's super easy for you, talking about how are you powering the lifters. That's evolved over time. I think it's different from the stuff that we were doing at NIAC, but
Yes, under the rule of life, to keep it simple, we are powering the climbers with solar power. Now that, frankly, between you and me, don't tell anybody, but there's a mystery that has to be solved for the first 40 to 60 kilometers, which is what makes things interesting. So we are looking at power being provided by the tether itself. I won't go through that rain dance, but there's a unique structure in the graphene and what's called pi orbits between there are ways to conduct electricity. So the basic answer is solar power, amplified especially for the first 40 to 60 kilometers on techniques that are still being developed. That would be the academic answer. We need to do a little better in 40 to 60 clicks.
The 40 to 60 clicks problem was answered under NIAC with lasers, and I always really had a hard time with that answer. So
yes, we have an answer.
Yeah.
Right. We don't have. We believe we don't have the answer.
Right. Correct. Yeah. Right. Yeah. I don't, let's see, I don't know if there's other questions. So Jorge asked about the location of the Earth near Ecuador. The original NASA NIAC document posited that it would be out a couple thousand miles past the Galapagos Islands, on the equator, directly south of San Diego, directly west of Quito.
Yes.
That's still probably the right answer, but as you said earlier, there's several locations that are also pretty good.
Yes,
it will definitely be located in the ocean.
Moved from number one, basically for security of carrying the payloads, like from Denver or from Atlanta all the way to the Galapagos, would have to go through so many stops. So right now we're carrying south of somewhere south of the Hawaiian Islands is the best spot. That answer was independently matched, I yelled successfully, by the Axis Mundi study, which was done by people in Tokyo. Yeah. There are, just to be silly, there are something like 37 acceptable points where a space elevator can send up and be effective. If you want to get worried, there's only one or two in the Atlantic because of the South Atlantic anomaly. It kind of aggravates everybody.
Imagine the world for a second, all the attendees and all of us on the panel here. Imagine a world where there's 37 space elevators pushing hundreds of tons a week into space. I mean, that's a world I want to live in. So keep up the good work there.
Yes, sir. That's what we imagine. That's right.
Yeah. Before we have to close off, I do want to bring up one thing that, we all talked about elevators a little bit. Tim, would you mind bringing up that slide that you have with space-based solar power? I would like to kind of tell a bit of a story about that. I know you're not really prepared for this, but it sparked it reminded me of something I think is relevant during this conversation. So as he's pulling it up, for those that are not familiar, space-based solar power is this idea that you would build enormous solar panels, and I mean enormous, maybe 5 kilometers on a side, a great big square, where there's other designs as well, but large solar panels, and you would emplace them in geosynchronous orbit over we just mentioned Quito. We'll stick with Quito. Imagine if you could build 300 of those, 300, and emplace them over the largest 300 cities in the world. If you could do that, you could power 40% of the global population with clean, green, limitless energy for everyone, everywhere, all the time. I mean, talk about transformative technology that would shift the entire civilization. And that was actually how I got into space in the first place. I was really interested in space-based solar power. I was inspired by Gerard O'Neill and some of his early work. And I originally got onto the space elevator project because there was no way to build that system. The rocketry just simply wasn't there. It wasn't possible economically or even energetically to build a space-based solar power system. So I decided I was going to get involved with the elevator as a heavy lift mass cargo solution. And that is still kind of my driving goal. So the elevators, whether Earth or lunar, to me are just stepping stones for that other larger technology of space-based solar power and clean energy for everybody.
Let me add to that, Michael. Same for me. I got into this because I saw the greenness of what we were doing.
Yeah.
I think, frankly, our presentation kind of understated that today. And
Yeah, that's why I wanted to bring it up. Tim, what's the price tag? What was the price tag on that space-based solar power system? I don't need the whole graphic. I just want to know what that number was.
3.5 billion for demonstrator.
Okay, so let me put that in context for a second. $3.5 billion. A single nuclear power plant that will not power a large city is approximately $4 to $7 billion. So let's say that's double the price that Tim just quoted. And that will only power one portion of one large city. But then that $3.5 billion, if you were to take that same amount of money, apply that to developing a repeatable robotic system on the moon, you could build the first one, and then you could build the second one, and then you could build the third one, and then you could build the fourth one, all the way up to the 300 that it would take to power 40% of the global population. So these are solvable problems, both technologically and economically. So I just wanted to, like, we kind of talked around a lot of stuff, but there was one piece in here that I really wanted to make sure was driven home, is that these are solutions that we build for space that have down to earth results. That's all. I just wanted to kind of throw that out there. Thank you.
Thank you, Michael. I don't want to keep us on just for the sake of using up the full time. And while I'm sure most of us here on the panel would love to continue talking, there's 50 of you all that have lives and families and fortunes to get back to. So we are fine sticking around for a little longer to answer questions, but I think that essentially concludes the formal portion of the panel. Yeah, and look forward to seeing you again in the near future.
thank you, Daniel.